Hello everyone, good evening. This is Pavan Gandikota, and today we are going to talk about a project where we will building a model to predict the electrical energy output of a combined power plant. So we were given a CSV file which have 5 columns such as temperature, ambient pressure, relative humidity, exhaust vacuum, and net hourly electrical energy output. So here we are going to talk about this project in two phases. One is a step-by-step approach of the project, and two is how we are going to develop this project in using Python. So the first step we are doing here is we are trying to identify the problem type of task, which is regression, as the target variable is continuous. We are using various evaluation metrics such as mean absolute error, mean squared error, root mean squared error, R squared score, which is the coefficient of determination. Step two, we are going to do some data exploration and feature selection. For the data load, we are using Python libraries like pandas to load and explore the data set that is already provided to us as a CSV file. As third step, we are going to prepare the data and also see if there are any null values available as part of the data that was provided. And then we are going to go for a model selection. We have multiple algorithm options, but for now we are using two models, which is linear regression and then a random forest regression model. Once these models are selected, we are going to train these models and evaluate these models to make sure which one actually gives us the better performance. And finally, we are going to display the output of the model using other options. So quickly jumping into the Python code, we are going to first define our dependents. So we are going to import pandas, we're going to import train and test split, we are going to import our linear regression and random forest regression models, so on and so forth. So as discussed earlier, the first step we are doing is to load the data that was provided as a CSV file, and we are uploading the data here. To make sure that all the columns are available, we are going to do a quick print of the data. As you can see here, we can see 9,568 rows and 5 columns. Then we are going to do a quick analysis of data. So here, if you can see, we are using the info function, and what it essentially is doing is giving all the columns that are available and the data types for the columns that are available. So once that is done, the next step that we are doing is doing some statistical analysis of the data. Here you can see there are two functions we are using. One is describe, which is actually giving us the statistics of that data. We have count, mean, standard deviation, minimum, so on and so forth. We are also using pair plot, which gives us the relationship between all the columns that are available. It helps us to visualize the relationship between the columns that are available in the CSV file. Then, as discussed earlier, we are going to look at the null values. And as we can see, there are no null values available in the CSV file that are provided. The next step that we are doing is we are doing a feature versus target split. X-axis is giving us the features and y-axis is giving us the target, which is the net hourly electrical energy. We are doing a quick print of the x-axis to check if everything is displayed properly. Next step, we are going to split the data. We are using 15% for test and 85% of the data for training. And here you can see we are checking the test data, which is 15%, 1,436 rows. And then we are also looking at the train data, which is 85%. After the split is done, we are going to train the model using the split. So first we are using the linear regression model, and here you can see we have trained the model. Once we have trained the model, then we are looking at evaluating the model using this statement. We are printing the actual test set data that was available, and then we are also printing the evaluation of the model that's available. So here, as you can see, the linear model has provided us the output, and which is pretty much closer to what we have in the actual test set. Similarly, we are also training the data, training the model, uh, which is the random forest regression model. And then we are following the same steps as above, and we are going to get the output here. Once these two models have displayed the outputs, we are actually evaluating which model is the best for our project. And we have figured out that the random forest model is actually the closest to our actual data set. Then we are performing our final evaluation using some metrics, and this is our score that is available using that metrics. And ultimately, we are actually giving a visualization of what's been done, which gives us the predicted versus actual values. This concludes our project. Thank you and have a great day.